In this video, we are going to discuss about the stability of a system by using a Routh array or Routh criterion. Actually, the given problem is construct a Routh array and determine the stability of the system whose characteristic equation is s power 6 plus s2 s power 5 plus 8 s power 4 plus 12 s cube plus 20 s square plus 16 s plus 16 equal to 0. And also determine the number of roots lying on the right half of S plane, left half of S plane and on imaginary axis. So actually the solution, the given problem is s power 6 plus 2 s power 5 plus 8 s power 4 plus 12 s cube plus 20 s square plus 16 s plus 16. So actually from this first one is, in this characteristic equation there are 6 roots. So it is a even number. Therefore, so we have to take the, for s power 6, so we have to take the even number, its even number of term and its coefficients. So even number is s power 6, its coefficient is 1. Next even number is 8. S power 4, its coefficient is 8. Next even number is s square, its coefficient is 20. Next even number is s power 0, its coefficient is 16. Then we have to take s power 5, it is odd number. Therefore, its coefficient is 2. Then next odd number is s cube, its coefficient is 12. Next odd number is s, its coefficient is 16. So now what we have to do? It is 2, it is 12, it is 16. Therefore, we can divide all the terms by 2. So therefore we will get s power 5, 1, 6, 8. So we will get the equations like this. Once again we can write s power 6 equal to 1, 8, 20, 16. Now s power 5 new term 1, 6, 8. So we have to find the s power 4. To find the s power 4, what we have to do? So we have to take previous equation. So we can consider this is a equation because it is a, these numbers are coefficient. From this equation, so we have to take 1 as reference. Then 1 into its previous. So like this we have to multiply 1 into 8 minus 6 into 1 divided by same 1. Next, so we have to take this same 1. Then we have to multiply with this 20. 1 into 20 minus this 8 into 1 divided by the same 1. Then again we have to take the same 1. Then we have to multiply with this 16 minus, here we can consider 0. 0 into 1, 0 divided by 1. So now s power 4 equal to 1 into 8, 8 minus 6, 2, 2. Then 20 minus 8, 12 divided by 1, 12. Then 16 we will get 16. All the terms are, this is 2, this is 12, this is 16. Therefore, we can divide commonly by 2. So it will become, s power 4 will become 1, 6, 8. So now we can substitute here 1, 6, 8. So now, so we can write, for our convenience, we can take the same s power 5. Once again we can write. It is a continuation. Therefore, s power 5, 1, 6, 8. S power 4, just now we found 1, 6, 8. So by using this concept, so we know we have to take this 1 and multiply with 6. S cube equal to 1 into 6 minus, we have to take this 6 and multiply with this 1. 6 minus 1, then divided by this 1. Next, we have to take the same 1 and multiply with 8. 1 into 8 minus this 8 into this 1. 8 into 1 divided by the same 1. Therefore, 6 minus 6, 0. 8 minus 8, 0. So, we will get 0, 0. So for this what we have to do? So, in case if row contains all values 0 means, so we have to take the previous equation. Sorry, this is the previous equation now. S cube equal to 0, 0. So its previous equation is s power 4. So s power 4 equal to, so that we can consider a auxiliary equation a equal to s power 4 plus 6 s square plus 8. So we know it will be having even number of terms. If this is s power 4, this is s square, then this is s power 0. So therefore we have to differentiate with respect to s. So you'll get 4s cube plus 12s. Then so we have to take this coefficient. Its coefficient are s cube equal to 4, 12. So we can divide by 4. Therefore we will get s cube equal to 1, 3. So therefore s power 3, 1 we will get 1, 3. So now, so what we have to do? So we can hide this. So now to get s square term, so we have to take this 1 and multiply with previous 6. So s square term equal to, so we have to take this 1 and multiply with 6. 1 into 6 minus, we have to take this 3 and multiply with 1. 3 into 1 divided by, the reference is 1. Then we have to take this 1 and multiply with 8. 1 into 8 minus, we can consider here 0. 0 into 1, 0 divided by, reference is 1. So you will get s square equal to 6 minus 3, 3. So we will get 3. So here 1 into 8, 8. So now s square equal to 3. S square equation is 3, 8. So now here 3, here 8. Then once again, so now to get s power 1 term, so now we have to take this 3 and multiply with this 3. 3 into 3 minus 3 into 8 into 1 divided by reference 3. Then there is no value here. Therefore s term equal to, so now we will get 0.33. So here we can substitute 0.33. Next s power 0. So from this, so to get s power 0, so we know we have to take 0.33 as a reference into its previous is 8 minus here 0 we can consider, 0 into 3 is 0 divided by same 0.33. So both will cancel, we will get 8. So s power term equal to 8. So now actually suppose in a row if all values are 0, so we have to take its previous equation as an auxiliary equation. So its actual equation is s power 4 plus 6 s square plus 8. So s power 4 plus 6 s square plus 8 equal to 0. So now we can consider s square equal to x. So it will become x square plus 6x plus 8. So now we know the formula to find the roots for auxiliary quadratic equation. Minus b plus or minus square root of b square minus 4ac. So we know here a equal to 1, b equal to 6, c equal to 8. So we have to substitute into this equation. We will get minus 3 plus or minus 1. So we can simply say minus 3 minus 1 minus 4. So therefore minus 3 plus or minus 1. Suppose if we consider minus 1 first here, minus 4, s square equal to minus 4. Suppose if we take plus 1, minus 3 plus 1 equal to minus 2, s square equal to minus 2. Therefore s equal to, so from this s equal to plus or minus j root 4. So we can say plus or minus j 2. Then if we take minus 2, s equal to plus or minus j square root of 2. So from this we can conclude the result is, actually if we take from s power 0 to s power 6 in a column, in the first column all values are positive, but in a particular row all values are 0. It means this 0 indicates that there will be a roots which are lying on the imaginary axis. So from that we can easily conclude the system is limitedly or marginally stable. Limitedly or marginally stable. Then first point. Then second point is, we see here these two roots are imaginary. These two roots are imaginary. Therefore 4 roots are imaginary. And the remaining 2 roots are lying on the left half of S plane. Left half of S plane, because here there is no sign change. Therefore, remaining two roots are lying on the left half of S plane. That's all about the two required things. So actually, in this Routh criterion concept, so if a row contains all values 0, so we can simply say there are some poles which are lying on the imaginary axis. So how many poles are lying on the imaginary axis? By seeing this step itself we can conclude. So in the previous step, its root is s power 4. Therefore we can say there are 4 roots which are lying on the imaginary axis. So in the result also we see here 2 roots, here 2 roots. Therefore 4 roots are lying on the imaginary axis. And in the first column, from s power 0 to s power 6, all values are positive. Therefore we can say remaining 2 roots are lying on the left half of S plane. Suppose if any sign changes occur, we can say how many time sign changes occur, that many time or that many roots are lying on the right half of S plane. Like that we can conclude. But here all values are positive from s power 0 to s power 6. So we can conclude that remaining 2 roots are lying on the left half of S plane.